So sometimes we want to be able to count the number of selections or samples. And we do that using what's called the combinations rule. So combinations here is just another name for selections. So when you want to count how many possible samples you could have, so the number of different samples of little n elements from capital N total, we write that capital N over little n with parentheses around it, and you read that as cap N choose little n. So n choose n. And it's defined to be cap n factorial over little n factorial and then times the difference factorial. Well, you can also write this as n c little n. That's combination notation, so selections or samples are the same as combinations, and the calculator has a built-in function to do this, so you don't have to worry about the factorials. So for example, let's say we want to know how many ways we can select a 5-person committee or sample from 20 people. So our cap n is equal to 20, and our little n is equal to 5. And on the TI-84, the key punches are you put in your cap n, you go to the math menu, probability, NCR function, put in your little n, hit enter. So like this. So we're going to go to the math menu, and then probability here, so arrow to the right, and then NCR right there. So let me clear out of here. So first we're going to do the 20, and then we're going to go to math, probability, NCR is number 3, so I hit a 3, and now I put in the 5. Oops. And enter. So 15,504. So 20C5, or if you want 20 choose 5, and the parentheses notation is 15,504. So over 15,000 different ways to select 5 people from a total of 20. Wow. So if you look at some of the lottery problems, they have 56 numbers. So your cap n is 56. I believe it's that way for Illinois. And you have to choose like 5 numbers or 6 numbers out of 56. And you have to match the numbers in any order. So this would be 56, choose 6. So let's go ahead and compute that one. So 56, math, probability, number 3 is NCR, and I put a 6 in there, enter. So let's see, that's 32,468,436, 32,468,436. So there's over 32 million different ways to select 6 numbers from 56 if order does not matter. That's number of selections or number of samples. So if you wanted to be sure that you were going to win, you'd have to do 32 million different combinations to be 100% sure that you were going to win. And then someone else might pick the numbers too, and then you'd have to split it. So no guaranteed winnings there. But that's selections.